Welcome to the discussion unit of this hour. We are going to talk about energy changes in physical and chemical processes. Okay, energy changes in physical and chemical processes. So first of all, let us start by asking ourselves, what is energy? What is energy? So if I ask you what is energy, most of the people are going to say energy is the ability to do something, which is true, okay? The ability to work, that is what you're talking about, energy. But now, when it comes to chemistry, we say that energy, let me move for you to see. So we say that energy come in different forms, okay? So the different forms of energy can either be, we can talk about chemical energy. Okay, energy can be, we have chemical energy, we also have electrical energy, we have heat energy, we also have which other type of energy? We have kinetic energy, and we also have what? Potential. And we also have potential energy. Okay, now let us take an example of a reaction. Now energy, before we even go to that, when you're talking about energy, remember energy is normally emitted or absorbed during a chemical reaction. Okay, so energy can either be released to the surrounding or it can be absorbed from the surrounding. Now, this means that during a chemical reaction, you can either have emission of your energy to the surrounding or absorption of energy from the surrounding by the reactants. Okay? Now, we say energy can neither be created nor destroyed, but energy can be converted from one form to another. Okay, now for example, we can say we can convert heat energy. Okay, we can convert heat energy to what? We can convert heat energy to kinetic energy. So we are talking about chemical reactions. Let me just give you an example. So let us talk about a combustion reaction. Okay, a combustion reaction, for example, when you're burning candle or when you're lighting a candle, what happens? It leads to the provision of which type of energy? We have heat energy. Okay, another type of energy that is going to be produced is which one? We have light energy. Okay, so those are some, that is what energy basically is. Now when you come to enthalpy changes, so we say, what is enthalpy? Enthalpy is the heat content of a substance. Someone else can also say enthalpy is the total energy of a substance. So this means we can measure the total energy or the heat energy of substances in a chemical what? In a chemical reaction. Okay? How can you express enthalpy change? Expression of the enthalpy change. Now, enthalpy can be expressed by doing what? By taking the enthalpy of the product. Okay? So we are talking about now in a chemical reaction. So during a chemical reaction, we have products and we have reactants. We say that enthalpy change is equals to the enthalpy of the product minus the enthalpy of the reactants. Okay, now you can see I've written here something that looks like a triangle and then H. So this one is what? This one is delta. So we can express enthalpy change as delta H because we've said enthalpy is denoted as capital H. Okay, now we have said everything that we're talking about involves a reaction. So we have two types, or classification of reactions. We have two types of reactions now. We have reactions that either absorb heat energy or release heat energy to the surrounding. Now we have endothermic reactions and exothermic reactions. So what is an endothermic reaction? We say an endothermic reaction is a reaction that is accompanied by absorption of heat. It is accompanied by what? By absorption of heat. What does this mean? It simply means that these endothermic reactions, during the reaction, okay, heat is going to be absorbed from the surrounding, okay, to the reactants. Okay, now this endothermic reaction, again we say the enthalpy, the heat energy, okay? The enthalpy, we have said enthalpy is the heat content. For someone else who have not understood, we've said it is what? It is what we call the heat content. So we are saying in endothermic reactions, the heat contents of the products, whatever has been formed, is normally, the heat contact of the substance that has been formed is normally greater compared to the heat content of the reactants, okay? This makes an endothermic reaction to be what? Positive. So we are saying in an endothermic reaction, the heat content or the enthalpy of the product is higher than that of the reactant, okay? Now, we can represent the enthalpy change of reactants using something that we call an energy level diagram. So these two are energy level diagrams. So this one is of endothermic reaction and this is for exothermic what? Reaction. So we are saying that in endothermic reaction, the heat content of the product is higher. As you can see, we have energy and we have the reaction path or the reaction process. So the reactants take in energy. During the reaction process, the reactants absorb energy from the surrounding, okay? And they're going to form a product whose heat content is going to be greater than that of the reactants. That is why you can see, that is how it looks like. That is why you can see the energy level diagram appearing as it is, okay? Now, when you come to the second type of reaction, we have said we have endothermic and exothermic reactions, two main types of reactions. So what is exothermic reaction? We are saying an exothermic reaction is a reaction that is accompanied by production of heat, okay? Exothermic reactions lead to the provision of heat or a release of heat to the surrounding, okay? So here we are releasing heat to the surrounding. We release heat to the what? Release heat to the surrounding. Now what does that mean? That means that the enthalpy or the heat, remember we said enthalpy is what? Enthalpy, I'm going to repeat again for those who don't understand. It is the heat content, okay? So we are saying the heat content of your product is going to be lower than the heat content of the reactants, okay? Why? This is because when the products are reacting, we are releasing energy, okay? And remember, when you're talking about enthalpy, we are measuring the energy. We've said enthalpy can also be defined as the total energy of a substance. So during an exothermic reaction, whatever you form, the heat energy of whatever you have formed is going to be lower than the heat energy of the 2 or 3 or 4 products that are the 4 reactants, yeah, substances that are involved in formation of your product. That is why you can see have the reactants here, and then we're saying we have energy given out. You see the direction of the arrow to give you now your product. If you look at this side, we have the energy. So we are saying the energy of the product is lower than that of the reactant. Let me show you. You can see where the energy. So if we are numbering, say this is 0, here we have 2, we have 4, we have 6. We have 8, we have 10, we have 12 on that side. So you can see the energy, and remember energy is measured in what? Energy is measured in forms of kilojoules, okay? So we are saying if we're looking at the measurement or the product or the energy of our product, the product will have an energy of what? 6 kilojoules, while the reactants will have an energy of what? 12 kilojoules, okay? On this is the side of the exothermic reactions, where the product is going to have less energy compared to the reactants. Why? Because the reactants are going to release energy during the whole chemical process, okay? Now those are the two types of reactions. Now when you're told to calculate, to represent it, the mathematical expression, so when you're told to calculate the enthalpy change of an endothermic reaction, what are you going to say? So we are going to say that the enthalpy change of our endothermic reaction is going to be what? Then I'm going to write up here, okay? So it's going to be enthalpy change, okay? The enthalpy change of our endothermic reaction is equals to the heat energy of the product. So of the product, we can write here of product. You subtract the heat energy of your reactants. Okay? So we said the heat energy or the heat content of the product is normally higher than that of the reactant. Okay? So let us come here. That is 0, this is 2, and then we have 4 there, we have 6, we have 8. Now, if you look at the heat energy of our reactant is going to be what? It is going to be 2 here, 2 kilojoules. So the reactant, the heat energy of our reactant is 2 what? 2 kilojoules. We say that is how you represent energy. Now, and the heat content of our product is going to be what? Our product is going to be what? 8. So it is 8 kilojoules, okay? Now, enthalpy change of an endothermic reaction, we've said it is positive. So it is going to be, the enthalpy change is going to be what? 6 kilojoules. Okay, now when you come to this other side of the exothermic reaction, let us see if you're going to have a positive or a negative enthalpy. So we've said, for example, here, when you're told to calculate again enthalpy change, you're going to say that, let me move to this side, we're going to say that enthalpy change is equals to the enthalpy of your product, you subtract the enthalpy of your reactant. Someone else can also say the enthalpy, someone else can also say that, how do you calculate it? Is it the heat content of your final minus the heat content of your what? Initial. Final is product, okay? Now it is the same thing because in some books it's written as final, but it is the same as product. Now, we're saying here we're going to say that the heat energy of our product is going to be 6. You subtract the heat energy of your reactant. The reactant is greater, okay? It's going to be, you subtract 12. What are you going to get? You are going to get the enthalpy change is equals to, so your enthalpy change is going to be negative what? Negative 6 kilojoules, okay? That is why we are saying the enthalpy of a product is lower than that of the reactant. The product is lower, it is 6 than that of the reactant, and it is going to give you what? A negative what? A negative enthalpy. These are some of the examples of the endothermic reactions and exothermic reactions. So endothermic reactions would be reactions such as electrolysis. You know the whole process of electrolysis, we've talked about it in our video below, you can check it out. Also, photosynthesis. Photosynthesis process is also what? An endothermic reaction. Now, when you talk about exothermic reaction, this one I know you know, which are some of the examples. These are, example is the reaction between an acid and a base. I'm going to write where? Just here. Or maybe here, yeah. The reaction between what? The reaction between an acid and a base. This is an example of an exothermic reaction where you're going to have heat energy being released, okay? Now, we say when a substance is dissolved in water, it involves exchange of heat energy, okay? So some substances dissolve in water, and during the dissolution in water, they evolve heat or they release heat to the surrounding. While other substances, once they are being dissolved in water, what happens is they absorb the heat energy from the surrounding, and the surrounding is basically what? Water. Now, let us take ammonium nitrate, okay? So solid ammonium nitrate, when you dissolve it in water, what is going to happen? So let us write the reaction. This is how you're supposed to represent it in an energy level diagram. You're going to write your ammonium nitrate, and remember it is what? It is solid, okay? You have to put the state symbol. So you dissolve it in water, which is liquid. We have said we are going to see what? We are going to see the ammonium nitrate, okay, solid, is going to absorb heat energy, or it's going to absorb energy from its surrounding, and its surrounding is what? Its surrounding is water. So here we are seeing that energy is being what? Energy is being absorbed for you to form your product, which is what? Which is simply aqueous ammonium what? Aqueous ammonium nitrate. Okay? So the heat energy we said, or the enthalpy change, we said it is normally positive. The enthalpy change of our ammonium nitrate solution is going to be positive what? Positive 25.8 kilojoules. Okay? Now, when you're talking about sodium hydroxide, on the other hand, the sodium hydroxide, when you dissolve it in water, you're going to lead to the formation of sodium hydroxide solution. Okay? Remember, we're talking about pellets, for sodium hydroxide pellets. Okay? Now, this sodium hydroxide solution is an exothermic solution, okay, because it leads to the release or production of heat to the surrounding. Now the heat is moving from the sodium hydroxide pellets to the surrounding, which is what? To your solution, which is water. So if you measure the temperature of water before dissolving sodium hydroxide, it is going to be lower compared to the temperature of your sodium hydroxide solution. Okay, now how are we going to write it in equation form? So we are going to say, we said the products are where? The enthalpy of the product is lower than that of the reactant. Okay, so our reactants are going to be there. Up here we have sodium hydroxide. It is solid. You react it or you dissolve it in water, which is your liquid. Okay, and you're going to form your sodium hydroxide solution, which is aqueous. And we have said the enthalpy change is going to be what? It's going to be a negative enthalpy change. Okay, so it's going to be that negative 43 kilojoules. So that is how you represent enthalpy change using an energy level diagram. Okay, so we have done more questions under enthalpy change. It's in our videos below. You can check them out for you to easily understand the whole topic of energy changes in physical and chemical what? Chemical properties.